Okay, test review for module 1, working with properties of functions. So we'll go through the questions on the review PowerPoint to prepare for our first test. Question 1. Two functions are expressed in the tables. Complete the statement to compare the functions. Your choices are f of x and g of x. By the way, the population in millions, this would be f of x. And the number of representatives would be g of x. So we have to determine which one is 1-to-1 and which one is not. For it to be 1-to-1, you have to have one x value, and the state would be our x value in this case, to one y value, which is our f of x and g of x. And then it has to go one y value to one x value. So they can only, there's no y's that can be repeated. So if we look in the first column, populations of millions, we can see that none of those numbers repeat and none of the states repeat. So I know that f of x is 1-to-1. But then if I look at the number of representatives, I can see here that 27 repeats. So it is 1-to-1 from the state to the number of representatives. But if I go from the number of representatives to the state, I have two that have 27 that are going to go to two different states. And that is not 1-to-1. So g of x is not 1-to-1. Question 2. Identify the maximum value of the domain of each function. Now remember, the domain is only dealing with the x coordinate, or the x-axis. So they're asking you for the maximum values. What is the highest x value that we have on this graph? And that is right here, because you just go to the furthest to the right on the x-axis, and that says that we have an x value of 3. So that is the biggest domain we can have. For g of x, you look down here, the greatest value on the x-axis, we go to the farthest right that we have a point at, and that would tell us that the greatest value is 6. Question 3. Identify each function as linear or nonlinear. So letter A, h of x equals x plus 11 divided by 8. Now this one, I can put this in y equals mx plus b format, because I can have this to be rewritten as h of x equaling x over 8 plus 11/8. So I do have my y equals mx plus b, so this would be linear. So just remember, we cannot divide by x, we cannot divide by y for it to be a linear function. Letter B, we have y equals -3 xy plus 16. Since we have xy together and we have a y over here, we can never have xy together for it to be a linear. So this would be a clue that this is nonlinear. And the last one, C, f of x equaling 1/7. So remember, f of x means y. So y equals 1/7. That means on the coordinate plane, it would be a horizontal line crossing the y-axis at 1/7. Since a horizontal line is linear, this function would be linear. Question 4. Identify the types of symmetry for each graph. Your choices would be line symmetry, point symmetry, or no symmetry. So number 4, this first one, upper left-hand corner, since the two sides are not, if we were to cut this in half vertically like this, they're not the same on both sides. We know it cannot be line symmetry. We could pick a point. If I pick a point here and then rotate this all the way around, try to match up with that, that still would not match up. So it cannot be point symmetry. So this one has no symmetry. The one on the upper right-hand corner. If we were to draw lines vertical, like here, they're not the same on the right-hand side as it is on the left-hand side. So it's not line symmetry. But if I had a point here and then rotated this around, it would line up with that line on top. So this would be point symmetry. On this last one is a parabola shape. If I were to draw a line right in half, you can see that this side is the same as this side. So we would have line symmetry. Question 5. Describe the end behavior of each function. So for these, we always want to start with as x approaches, we're going to go as x approaches negative infinity. What does the y do? In this case, if I go this direction, we can see that my y is going up to positive infinity. So I would say up to positive infinity. And then as x approaches positive infinity, when I go to the right, what does my y do? My y actually goes down, so that would be negative infinity. Second example on the bottom. Here, as x approaches negative infinity, what does my y do? So when I go to the left, my y stays constant. And what is the constant? It's a constant of 2. So no matter where I go to the left, my y is always going to be 2. And then as x approaches positive infinity, what does my y do here? So when I go to the right, my y stays constant as well, and it stays at 2. Question 6. Compare the extrema of both functions. So when we talk about the extrema, we're talking about the maximum and minimum here. So we can see we have a maximum here and we have a maximum here. By the way, I'm going to name this one f of x and this one g of x. They should be labeled on the test, so you can always identify them by the label that they give. So let's do this one we would do relative max. So relative max, we would have f of x. The relative max for here would be 0, 1, 2, 3, 4. So 0 and a positive 4. And for this one down here, we would have 0, 0. So g of x would have a relative max of 0, 0. Now let's do relative minimum. And we'll look at f of x first. F of x has a minimum down here, relative minimum. So we would call that one 2, 0. And then g of x. G of x actually has 2 of them down here. First one, the one on the left, would be negative 1 down to negative 1. And then we would also have 1 to the right, down 1, so negative 1. So that would be comparing the two extremes. Question 7. Use the description and a graph to compare the two functions. Which function has a lesser minimum? Which means which one goes lower as a minimum. So here we have a relative minimum. Here it says that it's at negative 0.4 and 1.1. So if I were to come over to this graph and I could label that one here, so negative 0.4 up to 1.1, that would be roughly right here. They're saying this one goes down about here. We can see that in g of x, the blue line, we have it all the way down here. So g of x would actually have a lesser minimum. Question 8. What is the minimum value of the function f of x equaling 4 times the absolute value of x plus 7 minus 3? So to solve this one, we would just need to find where is the lowest point of that function. And remember, the lowest point of the function is where our vertex is going to be. So to find our vertex, you would need to know what x is and then our y value is here. So remember, we can take x plus 7, make that equal to 0, because we need to know, is it going to the right or to the left, is the shift. If I subtract 7, I would have x equaling a negative 7. So this one, x is going to the left 7. So we go to the left 7, so that's at negative 7. And then this y value right here says that we are going down 3. So the minimum value of the function would actually be our y value, which would be a negative 3. If you were to put it as an ordered pair, you would just write negative 7, negative 3. I would allow that one, but really the answer that they're looking for is just the y value. Question 9, the equation of the function f of x is shown in the graph. So we need to write the function here, so we're going to label this as f of x. This is v-shaped, so I know that I'm going to have an absolute value in my equation. The first thing I would do is put my x inside here, and then we need to identify our vertex. Our vertex was shifted to the right 3. That means I need to have a minus 3 inside the absolute value. Always the opposite of what the x coordinate is. And then it went down 2, so that's a minus 2 on the outside. Now, one thing we want to look at is there a reflection going on? Is there a reflection? I don't see a reflection. You'll know there's a reflection because the graph is inverted, so it'd be like an upside down V. So I know there's no negative involved. But the next thing I need to know is my A. To find out my A, I need to find the slope. So if I go up 1, 2 over 1, I can keep going up to 1, 2 over 1, or I can go in the other direction, 1, 2 over 1, 1, 2 over 1, 1, 2 over 1. You can see that it matches. So I would have an A factor of 2. So this would be a stretch of 2 by a factor of 2. So my function would be f of x equaling 2 times the absolute value of x minus 3 minus 2. Question 10. Identify the reflection in each function as it relates to the graph of its parent function. So circle either x-axis or y-axis. So m of x is a quadratic. So the parent function would be of mx. So if we did f of x, this would be just x squared. Now, because I have a negative on the inside of the parentheses, my y value is always going to be positive when I square it. So therefore, it's only going to go across the y-axis. So this has a reflection over the y-axis because my y is always going to be positive. Now, if the negative 3 was on the outside of the parentheses, then it would be the x-axis. J of x equals negative absolute value of 5x. So this one is the parent function would be the absolute value of x. And we know with anything with absolute value, everything is positive. However, for this one, the negative is on the outside of the absolute value. Therefore, we're going to always have a negative y value coming in. In order to have a negative y value, it's going to be a reflection over the x-axis. And f of x equaling negative 3 times the absolute value of x minus 3. Again, the parent function is the absolute value of x. Because I have a negative on the outside, it's going to be reflected over the x-axis because my y's are always going to be negative. So this is x-axis. Question 11. Selena is planning a birthday party for her little sister at a local zoo. The price depends on the number of children that attend the party. The price per is normally $6. However, if there are more than 12 children in a group, the group can pay a $30 fee plus $2 per child. Write a piecewise function that best models the cost of the party C of x if Selena invites x children. How much would it cost 22 children? So our name of our function would be C of x equaling, and then we have to do a piecewise. And I'm just going to underline the main parts of our of our function. So we need $6 per child. And then more than 12. If it's more than 12, there's a $30 fee plus $2 per child. So originally, it's just $6 per child, and X means a child. And this is if it's from 0, if X is greater than 0, but less than or equal to 12. So if it's 12 or less children, then it's going to be $6 per child. You notice I put 0 is less than X because you're not going to pay anything if it's 0. So it's not going to, you have to have at least one child in order for you to pay $6. Now, if you did put the greater than symbol in there, I would understand it. I would not mark that one wrong. The next part says a group will pay a $30 fee plus $2 per child. So $2 per child, so X plus 30. And this is if, and it says if the group is more than 12. So if X is greater than 12, they would pay $2 per child plus a $30 fee. Now the second question says, how much would it cost to 22 children? So for this, I have to look at my domain. So that's in this column here. 22 is not between 0 and 12. It's greater than 12. So I'm going to use this equation right here. So I'm going to put 2 times 22, then add 30, and that will give me the cost for 22 children. 2 times 22 would be 44. 44 plus 30 would give you a total of $74. Question 12. Are the following functions even, odd, or neither? And then prove your choice by solving algebraically. So right now, I can check just my exponents here. Since they're split even and odd, it's always going to be a neither. And then to prove it algebraically, if f of x is negative x, I just put a negative in. And this should be negative x cubed, which still give me a negative x cubed. Would give me a negative x cubed. Negative x squared would give me x squared. So I would have a minus 3x squared, and then I have a plus 4. Since the first term, this term, and this term are different, but the middle terms are the same, that's our proof that this is neither. The second one, this is even, so I would say this would be an even function. And to prove it, I would have if f of x is negative, if f is negative x, this should be negative x to the fourth minus 2 times negative x to the second. For this to be truly even, I have to have the exact same as what I started with. So negative x to the fourth would give me x to the fourth, because anything negative x times negative x is x, times a negative x is a negative x, times another negative x is a positive x. And then negative x squared is x squared minus times a negative 2 would still be in minus 2x squared. You can see that this is the same as what we had right here. So that's our proof that it is even. For it to be odd, the signs would have to be different for every single term. So like if for this one, if it was odd, it would be a negative x to the fourth plus 2x squared. Okay, but since nothing changed, this would be an even. Question 13. State the domain and range of the function in set builder and interval notation. So we'll do set builder first. So the domain set builder, remember, has braces here, and we would say x such that x, and you can see on the x-axis, the sides keep going out this direction. That means it's going to continue on to infinity in both directions. So x would be an element of real. And then to put it as a interval notation, since the x is all real numbers, it would be negative infinity on the low end and positive infinity on the right end, the right hand side. You'll notice I use parentheses because with infinity, it can never equal infinity because there's no endpoint. So we would use the parentheses on there. The range, dealing with our y. So y such that y has to be, and I look at the lowest point. The lowest point is when y is -2, and everything goes above that. So that would be greater than or equal to a -2. And then as interval notation, the lowest end is -2, and the higher end goes to infinity. And I have to use a bracket for this one because it can equal -2, but infinity, it cannot equal, there's no set number to equal infinity, so it's parentheses. And the last question, question 14. Determine the transformation each function as it relates to the parent function f of x equals x squared. Write the function of each graph. And for this one, I'm just going to name each of these like g of x. So g of x equaling, and I need to find the vertex here. And the vertex here would be, it shifted from 0, 0 to -5, which would make this x plus 5 squared, and then it shifted down 3, so that's a -3. Next one, g of x equals, still a parabola here. I have my x squared here. My vertex now shifted to the right 3, so this would be a -3. Again, it's always the opposite of what the x coordinate is. And then it went down 5, so -5. Next one, g of x equaling primary vertex here. Here again, it went to the 5 to the right, so this would be a -5. And then it went down 3, so -3. And the last one here, we have g of x equaling, so it went to the left 3, so this would be x plus 3, and then it went down 5, so -5. So those would be our functions for each of these graphs. So the main thing that you need to remember is what is the vertex? The x coordinate goes inside the parentheses as the opposite of what they have on the number line. The y of the vertex goes on the outside, and if it's negative, it will be a minus. If it's above the x-axis, then it will be a positive. So those are the questions that you can expect on the test. They would just have different numbers.